Hey, what's up, chat? Welcome to Unit 8, Day 5. In this lesson, we're going to be writing equations for linear functions, and you're going to notice that we have already laid a lot of the groundwork for this lesson. So there's going to be a lot of things that you have already covered, that we've already learned from previous lessons. All right, and so to write an equation for a linear function in slope-intercept form, there's two kind of things that you need to be able to identify. First, I like to start with identifying the y-intercept because that tells me an exact point on our function, okay? And so I like to start with the y-intercept, and then from there, I need to also identify the slope. And so once I have the y-intercept, then I can also use the points to determine the slope or figure out the slope in other ways. And then once I have my slope and my y-intercept, those are the two things that I need in order to write an equation in y-intercept, slope-intercept form. Want to remind us, right, that the slope in y equals mx plus b is the y-intercept rather is the b, and the slope is the n, right? And so those are our two sort of points that we need to know. All right, and so let's look at the first one. All right, so we're gonna write an equation by first identifying the y-intercept and then figuring out the slope. All right, so for this one, all right, I'm gonna start by figuring out my y-intercept. So my y-intercept is where it crosses the y-axis. It is crossing the y-axis at 4. Okay, so my my y-intercept is 4. All right, and now I need to find my slope. Well, to find the slope, I gotta find just another point on my function. All right, and then I can use that to rise over run, right, to determine it. So I'm going to start here, go up 1, so I am rising 1, and then I'm going back 1, 2, 3. So that is a +1 and then a -3. Okay, so it is going to be, my slope is going to be -1/3. Okay, and again, keeping in mind that this is a negative slope, all right, so it needs to be negative. And then from there, I just write my equation, right? So y equals m, which is my slope, which is -1/3, x plus my b, which is the y-intercept. All right, and there you have it. All right, and so again, this is pretty straightforward. We've been doing this throughout this lesson. So hey, I want you to go ahead and pause it, and I want you to go ahead and see if you can do the next two graphs on your own. Okay, all right, so our y-intercept, so I'm going to start by identifying the y-intercept because that is a point, and that is where it crosses the y-axis. It crosses the y-axis at -3. Okay, then I'm going to find another point. Okay, my first point that I encounter is that one right there, which is -1, or I'm sorry, 1, -1. So I'm going to do rise over run, 1, 2. So I went up +2, and then I ran +1. So my slope is 2/1, or just 2. Okay, so my equation then, y equals slope 2x plus b minus 3. All right, and then lastly, start by identifying my y-intercept. Right here, it crosses the y-axis at 0. So my y-intercept is 0, and then I need to find another point. Okay, another point is here, and I do rise over run to find my slope. So up 1, up 2, so I went up 2, and then I ran 1, and again I have another slope of 2/1, which is just 2. So my equation is y equals 2x, and my y-intercept is 0, so I don't need to put +0, just leave it as y equals 2x. All right, okay, now in the next one, I have a table, and I want to remind us whenever we have a table and we're looking for the slope, again, we remember that slope, right? Slope is rise over run, okay? And so when I am rising, I am moving along my y-axis. So to get the slope, I have to do the change of y, which is y2 minus y1 over, and when I'm running, I move along the x-axis, so it's x2 minus x1, all right? And so that is gonna be what I need to do in order to find the slope of a table, okay? And then for the table, my values, again, this is x1, this is y1, this is x2, this is y2, okay? I could go on and on, right? But those are what I'm gonna use, okay? And again, I like to just use the first two values, but you really could use any values in the table, all right? So to find the slope, I'm gonna do y2, which is -1, minus y1, so minus, and then it is -2, okay? Over x2, 0, over minus x1, -2, okay? And so if you will remember, when you have a negative and a negative, or subtracting that, that's gonna make that positive, so it's really -1 plus 2. Same thing here, right? It's really -1 plus 2, okay? And so -1 plus 2 is gonna give me 1, and then 0 plus 2 is gonna give me 2, okay? So my slope is 1/2, okay? And then my y-intercept, again, we gotta remember that is where I cross the y-axis, and really that is where where x is 0, okay? So the y-intercept is where x equals 0. So I'm looking in my table, okay? And usually you are gonna be given that one, where does x equal 0? Well, it's at -1. So that will be where I cross my y-axis, okay? And again, this is the point 0, 1. 0, -1, okay? And that is where it crosses the y-axis. So that's important to know. Really haven't emphasized that as much in this way, okay? But so again, slope y2 minus y1, x2 minus x1, and then the y-intercept is where x equals 0, right? And then now that I have my slope and my y-intercept, now I can write my equation y equals mx plus b minus 1. All right. So, all right. Again, this part is probably the only new part that you're gonna see in today's lesson. All right. So let's do another practice problem. I want you to pause it. I want you to use what we've done here and see if you can figure out the next one on your own, and then check it. All right. So we got x1, y1, x2, y2, okay? So we're doing y2 minus y1, so we got 6 minus 11, and then we got x2 minus x1, okay? So a negative minus a negative, that's gonna make that a positive, so I got 6 minus 11, and then 0 plus 1, okay? So 6 minus 11 is gonna give me a -5, okay, and then 0 plus 1 is going to give me 1. Okay, so my slope is -5 over 1, or just -5. And then my y-intercept, again, it is where x equals 0. Okay, so where I'm looking for the point 0, comma, okay, somewhere in my table. Or actually, no, I'll put that. Okay, that is going to be my y-intercept, all right? And so that is my y-intercept can be found here. So that is at 0.6. So my equation would be y equals -5x plus 6. All right. And lastly, this time we're writing an equation to represent this word problem. Okay, so Mr. Heisey, he paid $30 as an activation fee. Then he paid $25 per month. for a cell phone. Write an equation for this given situation, okay? And so we need to sort of understand that really the y-intercept here is kind of like our starting point, okay? It's kind of like, where are we starting? All right, and here he has to pay $30, so that's how much money he's spending right off the bat. So before he has a phone, he has to spend the $30, so that is where our y-intercept is going to be, all right? So that is going to be the B, okay? So the $30, the B is the 30, okay? And then the slope, we need to remember, is the rate of change. So he paid $30, and then to determine how much more money he's spending, that is the slope. So the slope is going to be the 25 per month, okay? With, we'll say 25. I'm sorry, just 25. That is the slope, all right? And so the equation then is going to be y equals the slope 25x plus the y-intercept, 30. All right, so again, identify the y-intercept, identify the slope, and then write our equation. So, hey, you go ahead and pause it, see if you can do this last one on your own. Zanaya already has $25. Each week, her grandmother pays her $5 for doing chores. So she already has $25. Each week, her grandmother pays her $25 for doing chores, right? Write an equation for this situation, right? So the y-intercept is our starting point, okay? And that is the $25. So B equals 25. That is where we're starting, okay? And then the slope, right, is the rate of change. Okay, and she's getting $5 each week, right? So that is our rate of change. That is our slope, right? And so our equation is y equals 5x plus 25. All right. Oh, I'm sorry. Yeah, 5x plus 25. That's it. All right. Hey, and so in this lesson, we have learned how to write equations from graphs, from tables, and from real world situations. Hopefully you're seeing a lot of connection. Let me know if you have any questions, and we out.